Okay, now we're gonna go into current. Okay, just take note. There's three big components that three big things that we're gonna cover here. We're gonna cover current. We're gonna cover potential difference. And we're gonna cover resistance. Okay, these three are very closely related, but how do you distinguish between them is based on the definition. Okay, so the definition is the key here. Okay, now potential difference sometimes also can be known as voltage, which you will see later on. So just take notes. These are the three major components that we're going to cover. The first one of which we're going to cover is current. So current, what is current? It is the rate of flow of electric charges. So think of it as this is a charge. Okay, we are counting how many charges how many charges are flowing through a point. How many charges are flowing through a point every second. That is the definition of your current. Okay? So rate of flow of electric charges is equivalent to also saying that how many charges are flowing through a point every second. So you can see here is a measure of the amount of electrical charges flowing through a particular point every second. So this is your electric current. Now, for current, there's two types. Okay, there are two types of current that we'll be discussing on. First is what we call the conventional current. Okay, lousy color. Sorry, let's not use this. Let's use blue. Okay, conventional current is the flow of positive charges. Okay, so they are talking about the positive charges flowing. Okay, your charges that are positive is flowing. Okay, moving around. So the positive charges flow from the positive terminal to the negative terminal. So in this case here, you can see my current is flowing in this direction. Out from the positive into the negative. Okay, now scientists thought that current consists of positive charges, but this is actually a wrong concept. Okay, this is actually a wrong concept. Now, why is it wrong? Because if you remember your Sec 1 topic, we talk about atoms. They consist of protons, neutrons, and electrons. How are they positioned? Your nucleus consists of your protons and neutrons, and they are stuck in the center. The protons and neutrons cannot move. Okay? The electrons here are the ones that can move. Okay, the electrons are here. They are the one that's actually moving all around. Okay? And they are negatively charged. Electrons are negatively charged. So, can your protons move? They are positively charged. Can your protons move? No. But can your electrons move? Yes, they can. And electricity is actually a flow of electrons rather than a flow of protons. So in actual fact, it is the positive charge do not flow. Okay, positive charge, they do not flow. But negative charges are actually the one that's flowing. Negative charges are the ones that's flowing. Alright, so you can see here electrons, found electron shells, they are free to move. Right, free to move. So in metals, okay, why are metals good conductors of electricity? Because metals have free electrons. So you can see here, the electrons are actually free to move in the metals. Okay, they are freely moving. And when you start to apply, like when you put a battery near it, you put a negative part here, you put a positive terminal here. What happens is that the electrons will flow towards the positive terminal. Right? Flow towards the positive terminal. Okay? So, what impact does it make? So we know that actually the current flowing in our circuits are electrons. And so, the movement of electrons are actually the one responsible for current. You know, we define current just now as a flow of positive charges, but that's actually wrong. It's supposed to be the flow of negative charges. Okay? Current is supposed to be the flow of negative charges. This is your current. Okay? And what we term this is we term it as the electron flow. So now you can see here, Okay, this is my battery. The negative terminal is here, so my current actually flows this way. This kind of current we term it as the electron flow. Now we term it as electron flow. So on the circuit diagram, okay, you can see here we have the conventional current and we have the electron flow. So where's our battery? Our battery is here. Okay, conventional current is actually a flow of positive charges. It flows from the positive terminal to the negative terminal. Okay, this one is a positive. We talk about positive charges flowing from positive to negative. Okay, positive terminal to the negative terminal. So positive terminal of the battery, it flows to the negative terminal of the battery. How about this? We talk about electron flow. So we talk about negative charges. Okay, negative charges. So these negative charges actually flow from the negative terminal to the positive terminal. Okay, so take note, this is actually how your current flows. You talk about the flow of current. Now let's go specifically into the current here, the other things about current. So the units for current is ampere. Okay, the units for current is ampere. So we say that the current flowing through a light bulb, maybe 1.8 ampere. Current flowing through a kettle, 8.2 ampere. So take note, denoted the units is a capital A. Then how do we measure current? We use this instrument called the ammeter. Most of you have already done, looked at this before and you have done a bit of practical using it. So you should be quite familiar with it. One other key thing to take note is the ammeter must be connected in series with the circuit. Or it must be connected in series to measure the current correctly. If you connect it other ways, okay, it's going to be a problem. Now, you must also take note that the ammeter, you connect the negative terminal of the cell to the negative terminal of the ammeter. Positive terminal of the cell to the positive terminal of the ammeter. If you connect them wrongly, your ammeter will deflect in the wrong direction. All you need to do is to just swap the wires. Okay? Ensure that it's correct. If not, you can swap the wires. Okay? If not, you swap the wires. Okay? Now, so you can see here ammeter connected in series, okay, to measure the current correctly. Hey, somehow something happened. Okay, so if you need to draw a circuit that consists of a cell, resistor, switch, and light bulb, diagram looks like this here. Okay, ammeter, remember, it is always in, ammeter must always be in series. So that's the key thing here, in series. Okay, so this is the end for your current. Just remember definition well. Okay, the current definition is the flow of electric charges. Okay, it's the flow of electric charges. Rate of flow to be exact.